At a picnic, there are 10 diet drinks and 5 regular drinks. There are also 8 bags of fat-free chips and 12 bags of regular chips. If you grab a drink and a bag of chips without looking, what is the probability that you will get a diet drink and fat-free chips? So the first thing we have to determine is how many of each do I have? Well, drinks. I have 10 diet, 5 regular, so a total of 15 drinks. Chips. I have 8 bags of fat-free and 12 of regular, so I have 20 total chips. So now what I'm trying to do is find the probability that I'll get a diet drink and, in keyword when I use the word or see the word and means multiply. Fat-free chips, so fat-free chips. So now we're going to use what we know. Diet drink. I have 10 diet drinks. So I have 10 diet drinks out of a total of 15 drinks. Fat-free chips. There are also 8 bags of fat-free chips over the total of 20 chips. When I multiply and reduce, I get 4 out of 15. Which is approximately 0.267 or 26.7%. So I have 2 different problems here that are very similar. The first one says, find the probability of getting a king followed by a queen without replacement. Keywords without replacement. Second one says, find the probability of getting a king followed by a queen when you replace the card. So replace the card means I put it back. We talked about independent versus dependent events. Independent means when one event has no effect on the other. So independent means you replace something. So in this case, this would be independent. When you don't replace it, this would be dependent. So let's just solve this. So the first one says I want the probability of getting a king and, keyword, a queen. So I think about a deck of cards. I have 4 different kings. I could have a heart, a diamond, a spade, a club. And I have 52 cards. So I pull out a card, and that card's a king. Then it says I don't replace it. When I don't replace it, that means I now have 51 cards. I no longer have 52. But then the second thing says I need a queen. Well, I have a total of 4 queens. When I simplify that, I get 4 out of 663, which is approximately 0.006. If I round to decimals, I get 0.6%, which is not even 1%. The second one says find the probability of getting a king followed by a queen. So again, I'm finding the probability of the king and the queen when you replace the card. So the first thing, I have 4 kings out of 52 cards. So I pull one, whatever it is, I go ahead and I put it back. Then I get a queen, which is 4. Since I put it back, I still have 52 cards. When I multiply and simplify, I get 1 over 169, which is approximately 0.0059. I get it's very, very close, but I just wanted to show you an example of independent and dependent. Or when I move the decimal over 2 spots, I get 0.59%. Again, not close to even 1%.